Okay, this is the second part of section 2.3. We need to talk about inconsistent equations and identities. So when you follow the processes that we've been talking about in this chapter so far, sometimes you won't come up with variable equals number. So you might come up with an equation with no solution, or you might come up with an equation that's true for every real number, meaning you eliminate the variable. So after the variable is eliminated, what happens is you might get an inconsistent equation with no solution, and that's something that results in a false statement like 2 equals 5 or negative 10 equals 100. Those are not true, so that's inconsistent and there's no solution. If after you eliminate the variable, you come up with something that's true for every real number, which is what we call an identity, and that looks like 5 equals 5, or negative 10 equals negative 10. So let's try number 10. So, of course, the first thing we have to do is simplify on both sides of the equation. So we need to distribute first on the left. 2 times x is 2x. 2 times 4 is 8, so 2x plus 8. And on the left, we might as well go ahead and combine like terms. So 4x minus 2x gives us a 2x. And 5 plus 3 gives us a plus 8. So now we subtract the x's. So subtract 2x from both sides of the equation, and we end up with 8 equals 8. That is an identity, which means there are infinitely many solutions. It does not matter what number we put in for x, any number we put in is going to make this a true statement. Okay, now you should pause and do number 11 on your own. Hint, remember to multiply both sides of the equation by the least common denominator before you start doing anything else. It will make it look less scary. Okay, now that you have hopefully attempted to do number 11 on your own, we have x over 3 minus 7 equals x over 3 plus 5. Well, remember these plain old numbers here have 1 in the denominator. So our least common denominator is going to be 3, because anytime we have a 1 and no other numbers except for, in this case, a 3, then the least common denominator is always going to be whatever is not the 1. So let's multiply both sides by 3 over 1 of both sides of the equation. So we have 3 over 1 times x over 3 minus 7 over 1, and that equals 3 over 1 times the whole right side of the equation, which is x over 3 plus 5 over 1. So now we have to distribute. So we have 3 over 1 times x over 3 plus 3 over 1 times negative 7 over 1 equals 3 over 1 times x over 3 plus 3 over 1 times 5 over 1. So, as you can see on the left-hand side, 3 over 1 times x over 3, the 3's cancel and leave us with an x. 3 over 1 times negative 7 over 1 is negative 21. And that equals, okay, again we have 3 over 1 times x over 3. So our 3's cancel. That leaves us with an x, and then plus 3 times 5, so plus 15. Now again, we subtract x from both sides of the equation because we want to get our x's on the same side. The x's cancel on the left-hand side and the right-hand side, which leaves us with negative 21 equals 15. That is not true. So this one is inconsistent. Which means there is no solution to that equation at all. It doesn't matter what number we put in for x, we can never find a number that makes that statement that we started with true. So that wraps up section 2.3. And next we'll tackle section 2.4.